Okay, so welcome back to our I think it's the fifth video about Unity's audio. Yep, I know, it takes time. I'm sorry. Again, I am happy to say, like, yeah, I'm way busier than expected, and I'm also, like, a bit sorry that, like, it's not picking up the pace I would love it to take. But there again, I'm persistent, and again, those videos will pop up every once in a while. And in regard for a new video or no new video, do feel free again to approach me and send me any kind of question you have, whether it's like, LinkedIn, Instagram, my website, or whatever. It's all gonna be fine. So yeah, in today's video, we're gonna add some sounds to the coins that appear throughout our level. Let's have a look. And you'll see that in our game, as I said, again, whenever the red runner is gonna collect a coin, we're gonna have this particle effect, and woohoo, yeah. Now, before we actually gonna dive deep into like how we're gonna implement it and building the code and blah blah blah, I wanna first have a quick look about the overall Red Runner game's mechanics to have a bit of understanding of what are we gonna start working on today, because it's gonna be relevant to the coins, but also to the enemies we're gonna later on implement sounds for, and for the water, and so and so. But before we continue on, it's very important for me to say that if you haven't watched the first 4 videos and you have no idea about Unity or C# or Unity's audio, if you do know about C# and stuff like that, then go ahead, watch the video. But if you have no knowledge about it at all, I do recommend you go back and watch those videos, because again, I'm not gonna, explain again what are those basic building blocks, what is an audio clip, and for sure I'm not gonna go over the things we already talked about when it comes to C# scripting. Again, nothing too fancy when it comes to C# scripting here, only the basic stuff that are relevant for our audio system. But yet again, if you don't know what a semicolon is, it's gonna be very annoying for you to follow up. So do make sure you watch those videos. Okay. Now, as I said, let's dive just a bit for the Red Runner's mechanics here. Let's sum it up, and you will see that as we start the game and we play, we're always gonna have the same first, block here. You see, we always appear in the same place. It's always gonna look the same. But as we're gonna play the game, the map is gonna change. And since I always get this level. I hate this level when the maces fall. It's like it slows you down. Never mind. But again, because it's a runner game, as I said, you can run as long as you want until you die or just quit the game. Now, how is it possible for the game to actually keep creating a map? It's not like, some kind of programmer actually created a very long map, but they created several different kind of blocks that are being automatically, I'm gonna die now. They're gonna be automatically generated, as we run through our game. And let's have a quick look on it. If we go to the project and into the prefabs, you will see this folder here called blocks. And you will see we have all of the different names for blocks. We have all of those different parts. We're gonna have the start, again, as I said, which is always the same. Wait, let's press start and move my camera so you can see it. Okay. Wait. Okay, yeah, there you go. So you see the start is always the same. Okay, look at the part here. This is the relevant one over here on the side. You probably recognize it by now. It always looks the same. And the game will automatically call those block prefabs. And as you can see, again, they always stay the same. But again, it's always going to call them randomly. So the map will always look different, because it's going to call block 5 and then 12 and then 3 and then 5 again, but then 15. But if you died or something, then it's going to call 9 and then 1. You get the idea by now. Now, if you look closely, each of those blocks already has coins in them and water, and also those saws. Those prefabs are quite fixed by now. So if we want to add sounds to those coins or stars or whatnot, we're going to do it inside the prefab. Now, I need to talk about something. Wait, let's move my camera again. I need to talk about something that is going to be very annoying here. Each block is a prefab, okay? As you can see. And inside each block, as I said, we have the grass, coins, enemies, and stuff like that. Now, if you look under the collectibles folders inside the prefab folder, you're gonna see we have prefabs for coins as well. So you would expect, if you followed up until now from the last videos, that all of those game objects inside our blocks, like the coins one, are gonna be like, just like, copies of this coin prefab. Now, I don't know why. Maybe it happened when I initially made the sound for this game, when I tested it and I tried it. Or maybe this is how I just downloaded the game. I really don't know when or why, but this main coin prefab and all the other prefabs, by the way, got disconnected or were disconnected from the actual game objects inside each block prefab, which means that if we want to add all kind of components to the coins, we need to do it locally on each block, which is highly annoying, but we're going to do our best to keep it as smooth as possible. And you will see that eventually it's not going to be that much of a trouble. It's just going to add eventually extra 1.5 minutes to our work. Now, I checked it with a very talented friend of mine that is a very talented programmer in Unity. We worked a lot together and he was like, I don't know, man, it feels like you're fudged. And I asked ChatGPT and he was like, I don't know, man. And so if anyone out there knows how I can reconnect or assign those to the main prefab, please let me know. It can save up some work. Now, one of the things that's gonna lead us throughout our implementation here is how we're gonna make it as efficient as possible. And one of those features of efficiency is because I'm gonna add components to each coin, how I can do it in the minimum work as possible and how I'm gonna keep them yet all sounding the same and acting the same. Okay. If something here is not understandable by now, if it's not super clear, do feel free to send me messages. Again, I will gladly explain it. I do believe, though, that if you'll dive into the game, you will instantly understand it and get it. Okay, so without further ado, let's doop-de-doo and start implementing our sounds. So one thing that is important to know that if a game object in a game is using a script or several game objects is using the same script, if we're gonna change anything on this script, it's gonna be relevant to all the game objects using it. For example, in our case, all of the coins are using the coin script here. So if I'm gonna change stuff inside the coin script, it's gonna affect all the other coins that are using this script, which is quite helpful in our situation where again, we have game objects that are disconnected from our prefab. Now, because we're having coins, again, I think we have almost 99 coins game objects here. It's quite a lot. And because they're always regenerating and potentially they can just regenerate infinitely, it's as long as the player is playing, we're quickly gonna have tons of audio sources in our game if we actually gonna add audio source per coin. Because again, the red runner is running and we're having a sound for each coin, then they're just gonna generate in our scene, which is quickly gonna clog up our memory and it's not very efficient. Now, there's no need for each coin to have an audio source as long as the coin exists. I only need the audio source to play the sound when the red runner is collecting the coin. And after he collected the coin, I want the audio source to be thrown out of memory. So the second part of our system, which is supposed to be, again, as efficient as possible, is to be as cheap as possible on the memory usage here, which in our case means that we're only gonna generate or instantiate an audio source if the red runner has collected a coin. If he has not collected a coin, I don't want that audio source to live in our scene. And if there's tons of coins appear because the player is playing for some time now, but he hasn't collected any coin, then I don't want any audio source to be in my scene. Okay. The first thing I'm gonna do here is declare a serialized field. Okay. I'm gonna declare a game object, sorry, and I'm gonna make it a serialized field, so it's gonna be available in the inspector. You will see why later on. And this game object is gonna be called coinSFX game object. Okay, I'm trying to keep the naming here as clear as possible for me to later work on it. And also, I want again to know exactly what each variable is gonna be, because it might get confusing. Now, because it's serialized field and we declare the game object, wait, let's go back to our, you see we are having this tab now opened here in our inspector. We're gonna later on just associate the coinSFX prefab, and you'll see how it's gonna get useful down the road as we continue to build this script. Second thing I'm gonna declare is an audio source, and it's not gonna be available in the inspector. There's no need for it. Coin, and we're gonna call it coin audio source, and this is actually gonna be the audio source that's gonna play the audio clip. Now right now it's not associated with any audio source. I just declared a variable inside this class of type audio source. Later on we're gonna tell it which actual audio source in the game is gonna be equal to this coin audio source. Again, don't worry about it. Now I do recommend that as you build your audio system in your games and you're trying to associated sounds with different kind of objects in your map, and you have scripts belong to them, do go over the existing script, because there might be some stuff that even if you don't know coding so much, it might give you hints about where I should implement my stuff. For example, because we're collecting coins here, you can see all kind of functions like on trigger, on collision, which can help us, I can guess what it's gonna be responsible for. And we can see that under all of those functions, we have the collect function, which lives just here. And under this collect function, we have all of those different stuff that are supposed to happen that really looks like, again, reasonable. That really looks like a place that actually creates all of the different action that happens after the red runner collects a coin. For example, coin value ++, probably adding another coin to our inventory, set trigger of something, particle system .play. Yes, it makes sense that this is where we're gonna need to call our audio as well. I don't want to add all of my coding lines under this function. I want to call my audio function from this function, and by that, keeping this script actually a bit cleaner and more easy to understand. And again, you will understand it as we build our code here. So next thing I'm going to do is type down void, and let's call it a collection audio. Collection audio? Yeah, I wrote it proper. Yeah, it's proper. Parentheses, curly brackets. Next thing I'm going to do is I'm gonna declare a new game object, and I'm gonna call it inst game object, which means instantiated game object. Now, instantiate is the first new function we're gonna talk about. You can think about instantiate as like a fancy word for creating a copy of. So what I want to do here is whenever we're collecting a coin, is creating a copy of a prefab. This prefab is gonna be the actual coinSFX, it's gonna be the game object with the audio source on it. So whenever we're calling the collection audio, I'm gonna instantiate the game object with the audio source. Now, in order to do so, whenever we're calling the collection audio function, we're gonna declare a new game object, which is called inst game object, which stands for instantiated game object. And this one is gonna be equal to instantiate, which means I'm telling Unity instantiate something, and it asked me for a game object, and the game object is gonna be, you guessed it, the coinSFX game object. Now, as you can see, he asked for a transform. Transform is just a location on the scene. Because we're instantiating a game object, it should live somewhere on the scene. Now, because we're using a 2D audio, the location on the actual scene or the proximity to the red runner or to the audio listener is not going to affect how we're gonna hear the sound. If it's gonna be a 3D sound, the transform would be crucial here. In our case, it's not crucial at all, so we can just keep it out. And semicolon. So right now, whenever the collection audio function is gonna be called, we're declaring a new game object, but this new game object is gonna be equal, or is actually gonna be this new coinSFX game object that is gonna be instantiated. Again, this is the game object here that is gonna be associated with a prefab that we're going to associate later on. Again, if this is all C# scripting mumbo jumbo, don't worry about it. Follow my steps or send me a question. I promise you're gonna understand it. Okay. Next thing we're going to do is we're gonna access the actual audio source component on this game object. In order to do so, we're gonna call the coin audio source we declared earlier. And we're gonna set this audio source is gonna be equal to the instantiated game object dot get component, which is a function that allows us to actually access a specific component on the instantiated game object. And the component, and the component is gonna be of type audio source. Because it's a function, we need to add the parenthesis and semicolon, sorry. So right now, just to go over it, to make sure it's clear, after we declared that this game object is gonna be equal to the coinSFX game object that's gonna have audio source on it, we said that the audio source inside our class is gonna be equal to the audio source that is located on this game object using the get component function. Again, a get component function is a function inside C# and Unity that allows us to actually access a specific component on our game objects. Okay. Now, after we declared, you can see C# already guessing what I want to do. But yeah, after we declared what game object are we going to instantiate, and after we actually accessed the audio source that is located on this game object, all we are left with to do here is to actually access that audio source that right now it's equal to the coin audio source and tell it to play like we learned so far, that play. The last thing we're left to do here is to actually decide when we want to call this collection audio function. And as I said before, I want to call this function whenever the collect function is being called. So we're just going to type here, collection audio. And because it's a function, we add parenthesis, semicolon. And basically, that's it for the C# scripting part. The only thing we're left to do here is to actually associate our prefab to the coinSFX game object here. So let's go back to Unity. And we needed to create an audio prefab folder several videos ago. And let's move our audio prefab here. And let's go back to our scene and let's create a new game object. Let's call it coinSFX. Let's add an audio source. Cool. And right now we actually need to bring in our actual asset. So UI coins. No, let's just drag this whole thing here. Now again, it's just SFX I took from Soundly and just throw it inside my game. Soundly, again, it's a great platform. Highly recommend it. This game is not, this video series is not about, again, creating and sound design the actual sound. It's about implementing them. So I do encourage you to create a bit more of, like a bit less generic, sounds than I have here. But yet again, do as you like. I just like to, sounds that I think will fit my game. In our case, it's just like, a very, hooray, you collected a coin kind of sound. Okay, back to our business. Let's go to the coinSFX here and drag and drop the audio clip here. And let's go to our audio mixer UI. Let's duplicate this button and call it coin collection. Yeah, good. And let's make sure it's properly on all the views. We don't need the master view. We don't need the red runner view. Only here. Great. Colors. Let's make it blue. Cool. Go back to the coinSFX. Again, I'm just like flying by those steps because by now you probably should have, again, you probably know about those steps by now. And let's take the coin collection and add it here. Cool. So right now, this audio clip on this audio source inside this game object should play through our coin group here. Now, the last thing we need to do is actually to go back to our audio prefab folder drag this one here. We can delete this. And right now we have our coinSFX prefab. Cool. Let's go to our blocks folder, go to the start, and literally highlight the coins, those two coins game objects here. And you can see, again, the script has changed for both of them because we actually changed the global coin script. Lock this one, go to the audio, and literally drag the prefab over here. Let's press play and pray. Okay. Audio mixer. Let's see if we're getting our audio here. Play and hooray! We're playing our sound. But do look over here. You see this coinSFX clone? Let's play. Look like I'm gonna collect the next coin and look this like, you know, we're gonna instantiate the game object here. Okay. And this is like our actual prefab. And right now, even though we're not creating an audio source for each coin in our game that is gonna be generated, whenever we're collecting a coin, we're gonna, it's not gonna work. Because yeah, right now you can see it tells me, hey man, I'm missing like, you know, a reference here because the actual coin is looking for the prefab. Never mind, it's a bug we're gonna solve, don't worry about it. But even if I did, interesting. They still keep the audio sources, again, alive in the scene. With like, again, and if we're gonna collect it again, it's gonna add new clones. And as you can see, it's quite not efficient because I'm just literally creating audio source in my game. And if you remember, we said we want to be as efficient as possible. So only call an audio source when you collect the coin. And after I collect the coin, throw out from memory this audio source. So I want to actually destroy those clones here. So let's do that. So our last function for today is that after this collection audio function is being called, and we instantiated the coinSFX game object, and we actually accessed the audio source, and we told the audio source to play. After that all happened, we want to tell Unity, hey, you can take that game object and just throw it out of memory. Don't keep it alive in the scene. It's just a waste of resources. And in order to do so, we're just going to call the destroy function. And let's add a parenthesis, and you will see what it's actually asked us from. You can see that like, you know, the destroy function is looking for a game object. You can see the Unity and then that object obj, and then it has like, you know, this comma, float t. T probably represents time. Now, destroy function is looking for a game object to destroy, which is gonna be our instantiated game object or the inst game object. This is the actual game object we want to throw out of memory, and the float t actually tells destroy after how long. So I can say 1 second. So like, you know, as I collected the coin, it's gonna instantiate the game object, and after 1 second, it's gonna throw out of memory. Not very efficient. To be honest, like if we think about it, we only want to throw this game object out of memory when the audio clip has finished playing. Again, we can take the fixed duration of this specific audio clip and type it down, which is gonna be a bit, again, it's like non-efficient work. Let's say you want to have 3 different UI sounds that, like, you know, change a bit in length. We want to make it as flexible as possible that only after the audio clip is finished playing, then throw it out of memory, regardless of how long the audio clip actually is. So let's start typing this down. So the first of all, as we said, we need to destroy the inst game object, dot, and now we're just gonna declare the length of the coin clip. So we're gonna type down coin audio source dot clip dot length. So right now we tell them destroy the instantiated game object only after the length of the audio clip of this audio source that is associated with this game object has finished playing. So right now it doesn't matter if I'm creating like, you know, an array of audio clips for my you know, coin collection audio. Only after when a specific clip has finished playing, we're gonna destroy this game object. Let's clean this gap here and let's see if it works. Opa. Okay. And again, do make sure you look again on my hierarchy tab here. Let's play. And let's see if this coinSFX prefab is gone after it finished playing. Opa! Perfect. So right now, we have quite a neat system where it doesn't matter how many coins game objects is gonna actually live in my scene, regardless of how many blocks is gonna be created and all of those stuff is gonna be just like, throwing in my scene or being generated in my scene. Only when I collect the coin, only then I'm gonna create an audio source, and only when the audio clip is finished playing, we're gonna throw it out of memory. Now look, let's be honest about it, okay? These audio sources that like associated with coins, it's not wanna clog up our game, like our game can run perfectly with those audio sources. But I firmly believe, as I probably stated before in the former videos, it's a good habit, or it's a crucial habit, specifically in game audio, to always take optimization into account. And if you can create a system, and again, we created a system with 4 lines here, that is like highly efficient, then you should go that way or follow that route. Because again, you can work on other scenarios in other projects where this memory toll or memory usage toll is going to be quite pricey. Let's say it like that. Now, you can also say that like, hey man, calling in runtime to an audio source with an audio clip can also be a bit like, expensive on memory. But as you've seen, this game specifically can call the audio clip, like again, on the same frame as we collected the coin without any problem. And it goes a bit into like how we're actually adding audio files in our game, how we're compressing them and uncompressing them when we're actually calling them. We're gonna be talking about that way later in this like Unity audio series. Don't worry about that. Okay, let's follow the famous slide just to see it's all like, inside our mind properly. So, co-collection audio, the key functions here were instantiate, which is actually just creating a game object in our scene during runtime. As I said, we can think about it as a fancy word for creating a copy of. In our case, creating a copy of the coinSFX game object. We talked about destroy, which is just like taking this game object or whatever game object and remove it from our scene because we don't want it to live inside our scene or in the memory of our game. And we also talked about the game object.get component, and we said which component we want to access. In our case, we took the instantiated game object and we accessed the component of type audio source that we later called our audio clip from. So the first thing we did after we called the collection audio, we made a prefab of the coinSFX that we later on instantiated and declared that this game object is gonna be equal to the game object we're declaring inside our collection audio. After doing so, we called our audio source that we declared in the beginning of our script, and we said you're gonna be equal to the audio source that lives inside this game object that is equal to the instantiated coinSFX game object. After we did so, we just said to this coin audio source, you can play now. After it played, we call the destroy function, and we just say this instantiated game object, you can destroy that, but only after the length of the audio clip has finished. So only after our audio clip is played, you can destroy this game object, and by that, actually ensuring that we won't gonna have any cutoffs or whatever, even if the coin actual sprite or particles are out of our scene by now. Okay. Again, if you have any questions so far, do feel free to send them over if something here is not clear. Again, it took me a long time to have all of those stuff that are seemingly understandable. It took me a lot of time to actually understand them, okay? Again, this thing is very not intuitive, for sure for me. I'm an audio guy. It took me time to understand it, but right now I feel quite comfortable there. So yeah, just start dealing with it and typing it and getting bugs and getting errors and asking ChatGPT what's wrong with my script. And slowly, believe me, you will have this eureka moment. Now, as you've seen, we already associated our coinSFX prefab with the start block coins, but we haven't associated them with the rest of the coins, which created this weird bug where when we're collecting a coin, then we actually go past it and nothing happens. And we get like this console bug here. It's like it says, hey man, we're expecting something, but you're not getting it. There's a bug. This bug looks like that. We're unable to collect the coin. And again, it's just because we haven't associated our coinSFX game object to the rest of our blocks, or the rest of our blocks. Good. So this is the tedious part of the walk, as I mentioned in the beginning of this video. I'm going to run through it, but let's briefly have a look on how I'm going to do it. Again, this is the best and the most efficient way I found out to do it. So we're going to access the first ground, and we just can type here coin. The first coin that will always appear is just the parent game object, so it doesn't really have anything on it, but the coins that are gonna appear after, those are relevant coins. So you can just highlight this, lock it. You know what? No, let's make it even more efficient. Go here, add another tab, gonna be project tab. We can put it here, double click here, and let's say it's a 1-column layout. Lock it. Okay, you will see why I'm doing it. Go to the audio folder, SFX, go to the prefab audio folder and make sure the coinSFX is visible. Cool. And on the left side of the project tab, keep all of your block prefabs available. So now we can highlight this coin game object and literally just drag our prefab over here. Let's go to the middle ground one, type in coin. We can highlight all of those and drag and drop here. Go to the next one, type in coin, highlight all of those and drag it here. And you can see all of them now have like this prefab associated with them. Again, this is the most efficient way I've managed to come up with when dealing with this like disconnection between the actual coin prefab and all the game objects that are just like thrown around those blocks prefabs. And yeah, again, it's literally just a drag and drop. So like once you work a bit more smart in Unity, even those annoying things can be quite easy to handle with. And yeah, let's just go through and add all of our sounds to our coins. Okay, so yeah, it literally took me, I think, 2 minutes. That's it. We're having coin sounds for all of our coins in our game. So we can now get rid of this tab here and go back to our scene. We're in our scene, audio mixer. Let's clean the console. And yeah, let's see if it works. So now potentially you will be able to collect coins. Each coin is going to have the sound we need. It's going to be loading the audio source into memory only if we collected the coin and throw it out of memory after we actually finished playing the audio clip. Okay, the start is working as expected. Now I'm going to run away from a saw. Don't worry about it. And then soon, let's have collect this coin. Perfect. You see, still being kicked out of memory. Now, as you see, as we go further and further in the game, other game objects or blocks are not gonna be destroyed and get out of the memory, which is again not my favorite way of working, but maybe there's other considerations the programmers took into account here I'm not aware of. But as far as the audio system goes, I don't want to clog up the memory or just like, throw unnecessary stuff into our memory here. So, yeah. Opa. So, again, if you have any questions or anything you want to ask me regarding this video, if something is not clear here, do feel as free as possible to send questions over. I always love answering people that's like, highly passionate or really into like, game audio. It's a fascinating field, and I love those a bit of technical parts, so yeah, I would love to help, or to try and solve stuff together if they don't work, because it's happened all the time in this field. Next time on our video, wait, let's die for us to show it. Let's die. We're gonna add sounds to those water blocks. Now, it's actually gonna be the first time we're tackling 3D audio, because I want the audio blocks of the water to only play in proximity to where the red runner or the audio listener is. So right now, when I'm gonna run to the right, the water is gonna go to the left, and I wanna make the water sound like as if they're getting further and further to the left. And as I'm gonna approach water, I wanna make it sound like water is approaching me, slowly, to make it, a bit more understandable for the player what is actually happening in the game here. And if you remember from earlier, we had that saw that was chasing us. Right now, if the saw is out of our sight, like, on the left side of the screen, we don't know if it's actually close or far away from us. And this is where the audio can actually cue the player, the saw is getting closer. we're gonna deal with the saw after the water. But yeah, next time, 3D audio, adding sound to our water blocks. And yeah, goodbye everyone.